Mammoths include a number of extinct elephant-related species that once roamed the earth. They are most closely related to today's Asian elephants rather than African elephants. They looked similar to other proboscideans. They had long trunks and long, curved tusks. Whilst some species were exceptionally large, standing at 13 feet or 4 meters at the shoulder and weighing over 12 tons, most were smaller and a similar size to today's Asian elephants. The oldest known species is considered to be the South African mammoth, whose fossils date back 5 million years ago, during the early Pliocene. They were common in southern and eastern Africa. From there, mammoths migrated northwards, evolving into other species of the mammoth as they did so. Fossil evidence suggests that southern mammoths gave rise to steppe mammoths in Asia around 1.7 million years ago. Then, much more recently, steppe mammoths gave rise to the woolly mammoth. These species dispersed out of Asia, into Europe, and North America. The mammoths crossed over into North America via the Bering Land Bridge approximately 1.5 million years ago. From there, the American mammoths evolved into the Columbian, Jeffersons, and the Channel Islands pygmy mammoths. But more recent DNA evidence disputes the simplicity of this timeline, suggesting there was more of an overlap between species. It is likely with more and more scientific analysis of these incredible animals, our understanding will broaden, and their historic story will change over time. What we do know is that these large herbivores were well adapted to the climate of the Pleistocene. These adaptations may not be suitable for today's climate. More on that in a moment. The mammoths that inhabited more northern regions developed long fur to cope with the cold. The most famous of these was the woolly mammoth. These giants evolved several adaptations for surviving temperatures as low as -50 degrees Celsius or -58 degrees Fahrenheit. They developed a thick layer of subcutaneous fat to keep them warm. Their ears and tails were reduced in size to minimize heat loss, and they grew large humps of fat above their necks, which acted as both a heat source and an energy source. Mammoths were a common sight across the globe during the Pleistocene. But could they survive today? To answer this question, we need to compare the environment in which the mammoths thrived to the environment they would find themselves today. We can look at their habitat and diet, as well as the global climate during the Pleistocene. We also need to consider the competition mammoths were subjected to, and whether the same competition exists today. Firstly, let's look at the mammoth's habitat. During the Pleistocene, there were large areas of Eurasia covered in steppe tundra. This was where the woolly mammoths lived. It spread across the northern hemisphere from east to west, reaching as far south as Spain. The mammoths fed on the grasses, sedges, and shrubs that covered the steppe. In North America, the woolly mammoths inhabited this type of tundra as well, but there is fossil evidence that mammoths also inhabited forested regions in America's Midwest. Today, the mammoth steppe no longer exists. Between 42,000 and 6,000 years ago, 90% of mammoth habitat disappeared. The vast grasslands in the north have now been replaced by permafrost, taiga forests, and mossy tundra. These habitats and their vegetation could not support mammoths. There may be pockets of tundra-like grasslands around the world that could be considered suitable habitats for mammoths, although some of these are huge open areas like the Great Plains in North America or the Russian tundra stretching over 4,000 miles. They would unlikely provide the right sort of vegetation to feed these giants. This leads us to consider the diet of the mammoths. Mammoths were strict herbivores like today's elephants. From looking at fossilized teeth and feces, scientists have been able to determine their diet. They have also been able to extract preserved intestinal content from frozen mammoth remains in the Arctic permafrost. The Columbian mammoth ate cactus leaves, trees, and shrubs. This mammoth arose in Central and South America about 1 million years ago and was bigger and less hairy than the woolly mammoth. The Mongolian mammoth fed predominantly on grasses and sedges, with supplementation of dwarf birch and larch twigs, and a variety of herbs and mosses. The Eurasian mammoths fed on forbs, which are flowering herbaceous plants. These contained higher protein than other plants. The mammoths foraged for their food underneath the snow and ice. They fed on vegetation that was killed off by the winter frost, uncovering it with their tusks and feet. As the climate shifted towards the end of the last ice age, warmer and wetter conditions favored the less nutritious grasses and woody shrubs. The vegetation of the Arctic tundra changed, and woolly mammoths struggled to adapt to less protein-dense foliage. This change in vegetation could have led to the woolly mammoth's extinction. But there were other factors at play. Not only did the mammoths struggle to find enough to eat, but there was a new predator on the block. Modern-day humans were expanding their range dramatically. If we look at the competition and the threats faced by mammoths during the Pleistocene, many of the same threats still exist today. Whilst the changing climate caused a significant shift in the vegetation available in the mammoth's habitat, early humans are likely to have also contributed to the mammoth's demise. It is unclear how frequently early humans hunted and killed mammoths. Neanderthals were perhaps more successful at hunting these giant beasts. Judging by the evidence scientists have uncovered, both Neanderthals and early humans consumed mammoth meat, and the bones and tusks were used for tools and the construction of buildings. So far, the most accepted reason for the extinction of the mammoths is a combination of climatic and human factors. The majority of mammoths have died out by the end of the Pleistocene or early Holocene. Other threats include predation by some of the Pleistocene's most fearsome meat-eaters. Young mammoths were preyed upon by some of the large predators of the era: saber-toothed cats, cave lions, dire wolves, and cave bears would have hunted mammoths, especially the young and ill. Mammoths would have protected themselves with their tusks and come together as a herd when under attack. It is thought that they had a hierarchical social structure, like today's elephants, with a lead matriarch. Today, predators in the northern hemisphere include tigers, bears, and wolves. Some of these species are smaller than their prehistoric ancestors and would therefore pose less of a threat to a fully grown mammoth. However, those species that participate in cooperative hunting, like wolves, may be able to hunt down and tire down an adult mammoth or kill young or injured individuals. Fossil evidence suggests that a couple of isolated populations of woolly mammoths survived until as recently as 4,000 years ago. These populations were on St. Paul Island, Alaska, and an Arctic island called Wrangel Island off the northern coast of Russia. These isolated mammoths were safe from predators, but were thought to have died out from inbreeding and a lack of genetic diversity, as well as from the pressures of a changing climate. Today, many species are under threat of extinction from the same pressures: hunting by humans, encroaching on natural habitats, and the changing climate has seen the extinction of 160 species in the last 10 years. The negative impact of human expansion and encroachment on natural wilderness is a common theme when it comes to the demise of prehistoric and modern-day species. If mammoths were still alive today, their existence, like many other modern-day species, would likely be under threat. In conclusion, we don't believe that mammoths would be able to survive today. They are not adapted to the warmer, wetter climate of the Holocene, and their primary source of vegetation has been lost. They may be able to find pockets of refugia in some of the world's most isolated open landscapes, but it is unclear whether they would be able to survive on the vegetation found in these areas. Scientists have hinted at the possibility of being able to reincarnate the woolly mammoth, using preserved DNA from fossilized remains, and filling in the blanks with modern-day elephants. They suggest it may be possible to one day see a real-life mammoth roaming once more. Although this would be an incredible sight, the mammoths have had their time on this earth. The current Holocene presents a very different environment than that of the Pleistocene. The mammoths would likely struggle to survive, and their reincarnation would purely be for our enjoyment. Perhaps we should put more effort into preserving the species that are currently fighting for survival on this planet we, and so many others, call home. The Mastodon, a prehistoric relative of modern-day elephants. These large mammals weighed around 8 tons and stood at 3 meters, or 10 feet tall. They were typically shorter than today's elephants, but with more muscular legs and thicker-set bones. Some species had long, curved tusks, whilst others had none at all. They roamed North and Central America from the late Miocene, 11 million years ago, to the end of the Pleistocene, 10,000 years ago. The family Mammutidae, to which mastodons belonged, diverged from the Elephantidae, containing mammoths and elephants, approximately 27 million years ago. Whilst the Elephantidae lineage went on to become the elephants we know today, the mastodons became extinct at the end of the last ice age. But if they hadn't become extinct, could these prehistoric animals survive nowadays? To answer this question, we need to consider the conditions in which the mastodon thrived and compare them to today. Let's first consider their climate. Some have pictured mastodons as woolly elephants. Drawings and models depict a layer of visible fur covering them from head to toe, but there is no scientific evidence of this. There seems to be evidence that they were not well adapted to the cold at all. This is one of the reasons why scientists believe the great mastodons became extinct. They preferred habitats made up of dense conifer forests or swampland. They inhabited the Arctic during warmer periods in the Earth's history, when ice sheets didn't cover the North. Mastodon DNA has been found in Greenland. This was a complete surprise to scientists, as it was previously thought that these animals didn't venture that far north. But Greenland was a different place back then. Advancements in DNA sequencing techniques have provided us with a window through which we can see the past. Greenland was covered in greenery. Poplar and cedar trees, now only found in temperate forests, thrived. Caribou and mastodons grazed the vegetation. Horseshoe crabs, now found much further south, were abundant amongst corals in the coastal waters. Lemmings darted through the undergrowth. But when the ice sheets advanced and the dense forest gave way to the frozen steppe, mastodons migrated. Greenland became the harsh polar desert it is today, as the Ice Age gripped the planet. With their habitat gone, the mastodons struggled in the conditions. Their food sources and habitat dried up. But those that survived left the icy north and headed southwards throughout America to escape the advancing ice. The American mastodon now presided mostly near the Great Lakes. How many survived is not known, but it is thought that their population size contracted significantly. During the Pleistocene, the Laurentide ice sheet covered most of Canada and the northern U.S. But as the ice sheet began to recede towards the end of the Pleistocene, the forests began to return. There is evidence that mastodons were beginning to follow the reemergence of the forest in the eastern states before their ultimate demise, around 10,000 years ago. The theory of overkill has been put forward to explain the extinction of much of America's megafauna at the Pleistocene-Holocene boundary, but humans were already around for thousands of years before mastodons became extinct. Some suggest that the climate change pushed mastodons to the edge of extinction, and humans pushed them over. But it seems that had they survived the Pleistocene-Holocene boundary, then they probably would have survived the change to the climatic conditions of today. Although the world may have changed too much for the likes of woolly mammoths, it seems plausible that mastodons could survive in North America's modern climate. Now let's consider diet. Compared to other proboscideans, mastodons were much more specific to browsing. Analysis of their gut contents showed a preference for woody material, such as coniferous twigs. For this reason, they preferred to live in the closed forest habitats rather than the open grasslands. Further examination showed that they also fed on low, herbaceous vegetation, suggesting some pursued a more mixed browsing-grazing style of feeding. It could have been that their diet was determined by seasonal changes. Their reluctance or inability to graze grasses may have been the reason why they never made it to South America during the Great American Interchange. Doing so would have meant that they would have passed through large expanses of open grassland. Studies on the microwear of the teeth suggest that the vegetation and mushrooms consumed varied regionally and between populations. Their teeth structure differed significantly from other proboscideans, namely elephants and mammoths. Mammoths had flat, ridged molars that they used for grazing grasses, whilst mastodons had cone-shaped points on their teeth. They were used for crushing woody vegetation like twigs and leaves. They mostly ate from coniferous woodlands that were near ponds, swamps, and bogs. Although mammoths are closely related to modern-day elephants, there are similarities between mastodons and elephants too. They were likely very destructive like elephants, stomping down vegetation and knocking over trees whilst feeding. This probably meant that they had to continuously move from one place to the next. Today, over a third of North America is forested, with coniferous forests dominating in the west. Some of these are publicly owned, and others are private. Large swaths of the northwestern states are covered in temperate coniferous forests that stretch up into Canada's western coastline. Taiga, a type of coniferous forest, covers much of Canada, Alaska, and the northern states. It is plausible that these woodland habitats would provide enough food for a small population of mastodons. But to understand if they could survive in the modern era, it is important to find out exactly what caused their extinction. Of course, we can't know for sure. If they survived the fluctuating conditions of the Pleistocene and could survive today's climate, as many believe they could, what went wrong? It seems neither humans nor climate change were to blame entirely for their disappearance. They were one of many large mammals that became extinct at the end of the Pleistocene, called the megafauna extinction. Some researchers have put forward another argument for the loss of mastodons. Perhaps the most well-known proboscidean roaming North America during the Pleistocene was the woolly mammoth. Mastodons and mammoths walked side by side, but they favored different conditions. During the Pleistocene, the ice sheets expanded and retreated over millions of years. When they covered the north and arid icy conditions prevailed, woolly mammoths dominated the landscape. But when the ice sheets receded and gave way to the forests, mastodons thrived in the warmer, wetter climate. Newer radiocarbon dating evidence suggests that the mastodon population may have been rising shortly before they became extinct. Humans had been around long enough to have come into contact with mastodons. Whilst there is evidence that humans often hunted woolly mammoths, this doesn't seem to be the case for mastodons. That's not to say that it didn't happen. There are 3 sites where it appears mastodons were butchered by early humans, but it seems unlikely that they were hunted to extinction. Equally, they had survived the fluctuations in climate during the late Miocene and into the Pleistocene. So, this doesn't seem to have been a main factor. If their numbers were growing and their geographical distribution was so broad, then there must have been another reason for their demise. Large prehistoric predators like saber-toothed cats and short-faced bears were rare in the American Midwest where mastodons thrived. No evidence has been found to suggest adult mastodons were ever hunted by these carnivores. However, dens have been uncovered with juvenile woolly mammoth bones scattered throughout. If mastodons were eaten by predators, then it was likely the babies that were taken. But, judging from the fossil record, it would have been a rare occurrence. Although having few to no predators may seem like a good thing for the mastodons, it meant that there was an imbalance in the trophic levels of the food chain. The following highlights the importance of apex predators in the ecosystem. Scientists now believe that the mastodon's success was their ultimate downfall. The large predators were largely absent from their ranges, and mastodons thrived on the vegetation available. Whilst this meant that their population swelled, it also made them more susceptible to volatile conditions. A change in climate such as drought or the sudden outbreak of disease could rapidly affect the mastodons. They were more likely to fall into the dangerous cycle of boom and bust. During the bust phase of such a cycle, where numbers are at an all-time low, something else could have pushed them into extinction. This something else could have been climate change or hunting by humans. We believe that the mastodon could survive nowadays. The climate and habitat available to them are not all that different from what they lived in thousands of years ago. They would likely find enough food in North America's conifer woodlands. However, there could still be the threat of an unbalanced food chain. Would North America's predators help to keep the population healthy? Would bears take down young mastodons? Or wolf packs bring down adults? Who knows? One thing is for sure. If these giant elephant-like animals were reincarnated and released into North America's woodlands, they would have an impact on the ecosystem already established there. Their presence could lead to the destruction of woodland. However, if they had made it into the Holocene and modern era naturally, and the ecosystem adapted with them, then wouldn't it have been incredible to see them still roaming North America today? Deinotherium was an elephant-like animal that roamed the Earth during the Middle Miocene until the early Pleistocene. Fossils of these animals have shown them to grow to a height of 4 meters, or 13 feet, and weigh up to 13 tons. They browse the leaves of forests in East Africa, Europe, and the Indian subcontinent. Although they looked similar to today's elephants, there were noticeable differences. The most obvious were the tusks. Unlike modern elephants, whose tusks grow upwards from the upper jaw, Deinotherium's tusks curved downwards, growing out from the lower jaw. They were likely used for rooting around in the soil, as well as for defense. There have been debates among scientists as to what Deinotherium's trunk was like. In fossilized skulls, there is an obvious gap for a trunk-like appendage, but some have questioned whether this was more like the prehensile trunk of a tapir rather than the long trunk of an elephant. But given the height at which these giants stood, and their relatively inflexible necks and leg joints, it is likely that they had a long trunk to enable them to drink easily without kneeling or bending down too much. The skull of Deinotherium was less dome-shaped than other prehistoric elephants, suggesting a more cursorial lifestyle, perhaps to avoid predators of the Miocene megafauna. There are several separate species of Deinotherium known to scientists. The three most common were separated by their geographical location. Deinotherium indicum lived throughout India until about 7 million years ago. Deinotherium giganteum lived in Europe until about 5 million years ago. And the most recent to have died out was Deinotherium bozasi, inhabiting East Africa, specifically Kenya, until about 1 million years ago. But could Deinotherium survive today? To answer this, we need to consider their diet and habitat, and the climate in which they thrived. Fossilized tooth remains have revealed what Deinotherium ate. They are described as shearing browsers, possessing second and third molars with a stronger shearing action. The front teeth were used more for crushing vegetation. These prehistoric elephantids likely browsed vegetation from trees rather than grazing grasses. They may have used their downward-facing tusks to strip bark from trees or other vegetation. Judging by their jaw structure, they had very little side-to-side movement whilst chewing. They most likely chewed in similar ways to tapirs. The teeth that have been found belonging to Deinotherium have shown very little wear and tear. This suggests their diet consisted of soft, mostly leafy vegetation, rather than tougher or gritty plant material. It is thought that Deinotherium moved from forest to forest, largely ignoring the open savannas in between. When climate change began to shrink the forests, giving way to more open grasslands, Deinotherium began to die off. They relied heavily on forests for their diet, as well as for cover. Would there be enough food for Deinotherium today? African elephants can consume between 100 and 400 pounds, or 45 and 180 kilograms of vegetation a day. Deinotherium would likely have been similar. It would need a substantial volume of vegetation to survive. Comparatively few forested regions remain in Africa, Europe, and Asia, compared to the Miocene and early Pleistocene. In East Africa, the coastal forests stretch along the coastlines of Somalia, Kenya, Tanzania, and Mozambique. These would provide vegetation for Deinotherium, and they are tropical wet forests. Middle Miocene forest remnants have been found in the East African Rift Valley. Some of the flora identified are present today. The discovery of this vegetation has pointed toward a wet forest that once dominated the landscape. Perhaps not too dissimilar from the forests found on Kenya's coastal fringes we see nowadays. Early on in the Miocene, right before the Rift Valley formed, lowland rainforests that today are located in West and Central Africa stretched as far east as Kenya's coastline. Fossil sites indicate that later during the Miocene, which is when the Rift Valley was created, rainforest, montane forest, and thicket and wooded grassland dominated the landscape. Today, much of the Rift Valley is a fragmented landscape. The region has been deforested to make way for crops and tree plantations. Extensive logging and farming have changed the vegetation dramatically, and this has severely affected the biodiversity of the area. The most forested regions now predominantly lie along the riverways through the valley. Broad-leaved, deciduous, and evergreen forests dominated Europe during the Miocene. Today, less than 50% of Europe's forests remain. Just over 20% of India is covered in forests. During the Miocene, the majority of India's vegetation cover was comprised of evergreen, deciduous, littoral, and swampy forests. Later on, most of the forests and woodland gave way to open grasslands. Overall, the forests that Deinotherium relied on for food and shelter simply no longer exist. There are, of course, small pockets of fragmented forests that could provide Deinotherium with food and potentially suitable habitat, but would it be enough? And what's to say these forests will still be here in the years to come? Being such a large animal and having to consume such large quantities of vegetation meant that Deinotherium required a huge area to roam. Modern African elephants' home ranges can exceed 100 square kilometers. They require this amount of land to meet their needs, such as for finding food, mates, water, and resting sites. Deinotherium would probably require the same amount of space, but wild, untouched space is becoming more and more difficult to find in today's world. Elephants are sometimes culled when their numbers are deemed too damaging to the environment. By stripping bark from trees, they can kill whole acacia forests, wreaking havoc on the landscape. It is believed that Deinotherium also stripped bark, and therefore it would likely cause damage to vegetation. Having herds of gigantic Deinotherium roaming through Europe's remaining forests may not be the best thing for modern flora and fauna. In fact, introducing a new species, prehistoric or not, into an existing biome could have severe consequences for the ecosystem. So, what about today's climate? Could it be suitable for these prehistoric herbivores? The Miocene saw significant changes to the global climate that fluctuated throughout the time period. Before the Miocene epoch, about 50 million years ago, temperatures were cold and ice sheets formed at the poles. This colder climate continued into the early Miocene. But fast forward to the middle of the Miocene, when Deinotherium began to emerge on the scene, and temperatures rose dramatically. This period between 17 and 15 million years ago is known as the mid-Miocene climate optimum. Temperatures across much of the planet were 4 to 5 degrees Celsius, or 7 to 9 degrees Fahrenheit above today's average temperatures. There was a reduction in rainfall following the warming of the climate and the construction of mountain ranges. This led to a decrease in forests and the expansion of grasslands, which had significant impacts on the fauna at the time. Following the mid-Miocene climate optimum, temperatures once again cooled and became much colder as the Earth entered the Pliocene. The Earth was generally cooler and drier during the Pliocene, a trend that continued into the Pleistocene. Incredibly, the Deinotherium genus survived for about 10 million years, from the mid-Miocene through the Pliocene and into the Pleistocene. It lived through huge changes in the Earth's climate. There was a series of ice ages throughout these years with expanding polar ice caps and climate optimums with average temperatures warmer than they are today. Although these temperature changes were gradual, unlike today's global warming, it is still remarkable to think that Deinotherium survived significant fluctuations in global temperatures. This suggests that Deinotherium would be able to cope with today's climate. In conclusion, it seems that Deinotherium was an incredibly tough genus of prehistoric animals. It would likely survive conditions on Earth today. It lived in forests with a broad range of tree species and vegetation, and roamed on 3 different continents. The limiting factor, however, would be space. With human populations encroaching on what little wilderness we have left, forests across Europe, Africa, and India seriously diminished, and continued climate change, they, like so many species, would have an uncertain future on this planet in the modern era. That's all for today. If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. You can also leave a comment with what you would like to see in the following videos. Thanks for watching. See you next time.